Phil Beisel has gotten into a situation where he is now best friends with Elon Musk, or at least if you base it on the number of times that Elon is responding to his posts on X and the way that Elon's responding to those posts. And this is a really good week for that because it was right in Phil's wheelhouse. All the controversy that was going on Monday and following up on Tuesday and Wednesday. And I'm not sure it's resolved yet because the shock has had to get involved and Elon's come back a couple of times back and forth. But I know that Phil is going to do an amazing job of helping us understand, especially because it's about reasoning.
It's about reasoning, isn't
It's
it?
about reasoning. So Phil, it all started, of course, at the beginning of the week when Jensen Huang came out and I think maybe oversold his new product that has to do with autonomous vehicles. And I've done that in my life. I've oversold. I'm a crackerjack salesman,
Mhm.
and I sometimes exaggerate. I've been caught at that, especially by wives. They tend to notice it right away.
Yeah, they're good at this. But by the way, the entire audience is a bunch of tech bros that are like,
That's right.
yeah,
That's right.
right, yeah.
So yeah. So anyway, we already talked about it this week that Jensen actually probably lied a couple of times at the beginning of that part of the presentation, and especially in terms of them being the only one with end to end and blah 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 blah. So I'd like to have you kind of help us with a little bit more of the techie side and maybe with some of that back and forth that you and Elon had.
Yeah,
And maybe at the end of the day, we'll understand a little bit more, especially about the reasoning thing, because that's the one that got my brain cells going.
sure. I think it's super important. Now, so Elon made a public reply to one of my posts, and that lit up because he created his own little controversy bubble about what does 10 billion miles really mean? Is it equal to the safety counter that's on their site? Is it something else? Did he mean billion miles or did he mean kilometers? Because some people thought that he had confused the the units. Um, and he never clarified any of that to date, to my knowledge, and that's fine. I mean, it's fine for me. It's fine for me. And then he likes several other posts, and what I always say is if we don't talk about like club, like Fight Club, I don't wouldn't tell you which post he liked, but look, I made a bunch of posts this week, and going into that week about CES, I said to my very good friend, I said, watch what's going to happen. This is exactly what Jensen's going to do with regard to Tesla and so forth, and it played out literally, exactly. Um, so I mean, okay, what does it mean, and what is the real issue here? And maybe we should discuss what is the fear in the minds of maybe the potential investor. Uh, and of course, they would be saying to themselves, "Oh my gosh, look at this company, Nvidia, clearly there's the thing about AI has caught up or can compress and get there in soon time, whatever that means. Um, because they gave good presentation, they gave good demos pretty good. Um, and so that I think that's the fear, right? I mean, it's now the interesting thing about Tesla, I think, in this regard is that, Tesla's pursuit of autonomy isn't just about enabling. I mean, look, if the world looks at Tesla in the focused lens, Wall Street and a bunch of consumers still out there, you talk to, people that aren't in the Tesla hemisphere or zone, they'll say it's an auto company, right? So when they hear autonomy, they apply it to automobiles sold to customers, and then they think about how does that compete with Ford, General Motors, Mercedes, the legacy auto companies. Uh, and they don't run the the kind of story, which is the number one reason that autonomy is being developed at Tesla is for Robotaxi. And that particular platform makes the car sale business look very small by comparison,
Right.
right? And nothing in whatever Nvidia said, whatever Jensen's, they're not trying to enable. It's not like there was some kind of massive discussion about Uber partnering with Nvidia to, because Uber has big brand presence in rideshare, and that kind of story would be, I don't know, more alarming. I don't know what the right word for it is, but it would be more interesting, certainly. I mean, then you would ask Uber, where's your fleet?
Yeah.
Where you have no vertical integration. You're not.
Yeah, so I think what you're saying here is that General Motors, Ford, and Mercedes have no plans at all to put out a robotaxi fleet.
No, right.
They've not said anything about offering it as a B2B, as a bread and breakfast type of arrangement, or offering it as their own fleet. Then you've got Nvidia, who has no plan to build cars. They've said that. They've repeatedly said that. We know they
Right.
have no plans to build cars. And then you got Uber, who has no interest at all in owning vehicles, much less probably doesn't even have interest in coordinating with somebody else to own vehicles. And then you got Waymo, owned by Google, or mostly owned by Google, who buys cars from somebody else, slaps on somebody else's equipment,
And has their own AI stack.
and has their own AI
Yeah,
stack.
yeah.
So you've got nobody with the vertical integration and nobody with the vision. That's really what it boils down to.
Yeah, I mean, it's look, I mean, just to be very clear to anybody listening, I love Nvidia. Great company, great CEO, great products,
Yeah,
but the products are aligned. I mean, the entire thing is around selling chips,
yeah,
whether it's
yeah.
data center or inference.
Mhm.
And to date, the big money is really on the data center side, whether it's doing inference or not, meaning that,
Right.
in other words, edge-based inference in robotics, whether it's humanoid or vehicle robotics, autonomy,
Mhm.
is not something that they have really a hold on at all, right? It's because the products aren't really there. The only product that's really systematically coming online is in fact FSD, and that is based on Elon's proprietary chip, Tesla's proprietary AI 4 or 5 chip. So, um,
In fact, it's kind of interesting. All of the activity during this last week was around Robotaxi. And the reality is, I think that the bigger story might be around Optimus, because while I don't think anybody has a chance of getting anywhere close to the output that Elon is going to get out of an 8 million square foot factory,
yeah.
so I don't think there's any real problem there. But I think Jensen has a better chance of selling hardware that's going to be and software that's going to be used sometime soon in the humanoid space
You
than he
know,
does in the car space.
it may be true, and I think the design of what he's trying to do with those platforms is build sort of a analog real world, uh, it's called a vision based,
Mhm,
sensor based,
mhm,
for
mhm.
lack of,
Yeah.
um, AI system as a platform, kind of like mostly like, okay, we NVIDIA built up CUDA to be try to, I mean, in the case of CUDA, it was really, we're going to build a bunch of libraries that abstract the hardware so that you can move from chip series to chip series, and then we'll create libraries that do things that get you hooked,
Mhm.
because then once you get hooked into CUDA, then you can't like go switch to AMD with think about, we always have this thing going on in AI where everybody assumes that the teams assembled um, are like the XAI team or Tesla's AI team. No, no, no. The world, if you start looking at AI models or training way beyond the hyperscaler folks and the big ones, the big LLMs out there and so forth. Now you've got a team of people that, if you're doing it in medical, you're at Stanford, you're doing something in medical, you're going to use CUDA, because you're not going to go, you don't have a fundamental team that's going to start rewriting the,
Right.
the the core stack. They're not looking for performance. They're not looking for coherent clusters of hundreds of thousands of GPUs. They're looking for, a couple hundred GPUs running with the CUDA framework. And so it's a great lock-in to have built that SDK on top of the hardware, and effectively having had that success at NVIDIA. they can see that pathway right to this whole autonomy side. Um, and so now the problem is that they aren't the end customer. They're not vertically integrating this. They're not building cars. They're not doing any of these things. They're just offering it essentially as a reference platform to ostensibly the legacy automakers, which are wholly unprepared to integrate it. And I've got a post about that. I mean, they really are. It's if I look back at my time at Rivian, one of the most important things that I was involved in, I mean, the thing I did was effectively define our Rivian's software-defined architecture for the vehicle, which is a systemic, it's like rebuilding the entire brain and nervous system of the vehicle.
Mm-hmm.
And it is different than, say, an OEM, which when you look at the tech stack, it's really like, oh, we went out to Bosch or Continental, we bought we went to a supplier, we bought the infotainment system, we shoved it into the top hat of the car, and we called it a day. And that's not what happened at Rivian. It's not what happened to Tesla. And so now you have so companies like Rivian and Tesla, they actually have a platform to support an autonomy stack on top of it.
Right.
Okay. And that's a really important thing to be talking about, because now you've got companies that are like, okay, say we go to Ford. Okay, Ford has to somehow work its way into a clean enough architecture to support that integrating this reference stack, sensors, and so forth onto the vehicle. And I got news for you. That's really hard to do. I mean, I can tell you why it's really hard to do, because now it is almost 5 years that I worked deeply with Ford on a project relating to bringing Rivian core technology to the Ford product line.
Right.
Okay. And the amount of progress that they've made, including Rivian dissolving that relationship, it went nowhere. And so it's not dissimilar to, and I don't think it's really dissimilar to any US, German, or Japanese automaker, frankly. China's a different story. We'll leave them in a different box. But in terms of strictly US automakers, German automakers, these Japanese, these guys are not prepared to do anything at scale with an autonomy platform. So we it's not just about taking what they have and somehow slapping it on.
Right.
Right. It requires this entire architectural approach. It has to accept it, and that alone puts them, year 2 or 3 behind, because they cannot deliver anything. They can deliver demo, but not scale. And I wrote a nice post about that Elon liked. I wouldn't say that, did I? That talked a lot about the difference between demo and production ready anything.
Right.
I mean, if we recall, it's over a year ago. Is it fall of not last year, but the year before, that the autonomy that Tesla did We Robot down in LA demonstrated cybercab, the future of autonomy, and they're just about ready to call the to do SOP, start of production, right? It takes time to do this. Full self-driving, for whatever people say about it, the reality is it takes a lot of road miles to yard in that long tail of driving situational things to get to. And this is what, one of the things I said in that post is I said, just look at Tesla's ground game. Look at their ground game. They are at this 24/7. They have a team that if you show up in that parking lot at 11:30 on a Saturday night, the parking lot's full in Palo Alto. This team is guns a-blazing, and they're trying to get to the finish line for full autonomy for Robotaxi, starting in Austin and then, scaling out. And they're not there yet. Now, why are they not there yet? Because they're chasing that long tail. They're trying to get over they're trying to nail a certain set of KPIs, right? Key
Mhm.
performance indicators for
Mhm.
the saying, okay, we want this level, we've got to solve these problems and we've got to reach this level of safety or performance uh, to get this to unleash this thing.
Mhm.
And you know, they're they're what I'm saying is these guys are all in. This is what they're doing. This is their thing. Nobody else is all in, and they're still chasing the tail a bit, right?
Mhm.
Now I think they're very close to grabbing the tail and not to go crazy with analogy or something metaphor, but I think they're close to grabbing that tail and letting that thing go. It doesn't mean they don't keep chasing. This is an
Right,
infinite.
right.
It's an infinite tail. It's a software problem defined by the edge cases. It's literally defined by the edge cases.
And
Uh,
people leave out of the equation the customer satisfaction aspect of it. The you know you not only have the issue of the car not getting into an accident and maybe avoiding accidents that other cars would be in, but then you've got a customer that's going to get into this car who could be skeptical, they could be in a bad mood, they could be somebody that's a Tesla bull. You got this range of customers that are going to get into the car on any given day, and you want the experience to be absolutely flawless
yeah,
um,
it's
uh,
not.
in every way, shape, and form.
Yeah, it's not just about driving over, you know, train tracks or doing things that are, doing bad things in an intersection, or it's not just safety. I mean, safety is but the entire experience of the product. I mean, I would say to you that drop off and pickup is an extremely hard problem,
Right.
and that problem is not generally addressed by FSD, right?
Right.
It
Right.
is an FSD problem,
But it's a
but
lot
it's
of
not uh but it's not the front problem, and it's sort of like it's just as if when they got into 14 later releases, 14, what are we on, 14.2 and change, we start to see park to park being a viable thing. By the way, this is going to drive us right into the reasoning discussion, so that's
it.
good. But it's they're they're tackling a lot of those issues, like where is the appropriate person, where's the appropriate place to drop somebody off
Mhm.
that is both safe, convenient, and appropriate, like literally appropriate. Like
Right.
people have this, people instruct their Uber drivers, pull up a little bit more, go here, go.
Right.
And right now the interfaces in the car are not that fluid. They will be. There will be a point where the Grok interface is part of the customer experience with Robotaxi,
Mhm. Mhm. Mhm.
and that way you'll be able to talk to the car and it's very cumbersome to try to control the car with some user interface by dropping a pin or moving. That's garbage. You don't want to do that. What you want to say is to the car, what you say to the Uber driver, move up another 30 feet, or could you park in that driveway over there?
Right.
And without any of that, and by the way, you would assume that the customer never really has a conversation with you. You have to assume that the customer is not part of the solution to the drop off necessarily,
Right.
that you need to make the right decisions. And therefore, you've got to kind of set this. And it's complicated by there are pickup zones and drop off zones. It's been matured over the years with Uber, where, where do they go to the airport? You're not allowed to just drop somebody off. Airports have all these ride share, just to drop somebody off at San Jose. San Jose charges Tesla money to drop off somebody with a Robotaxi there. So they have to go through that whole handshake of telling them that they're here. They have to drop off and pick up at the right places. Um, and that stuff takes time. Like, I don't think people understand it takes time. Now, that's not the general customer autonomy problem that Nvidia is sort of ostensibly chasing. Um, but it does point out why. It just points out that there's an extremely long tail to
Yeah.
um, good decision making in the framework, and that should open up our reasoning discussion.
Okay. All right. So that was the place where, I get a little bit out of my depth. And so I didn't even read your article yet because I
Mhm.
wanted I wanted to I wanted to be able to engage with it as a neophyte, and then see if I asked the right questions, or are potentially, I'm able to explain it to one of my children or grandchildren. So here we go.
Yeah, so let's step back and talk a little bit about what is reasoning. Sounds like you're putting a human brain in the car, and I don't really think it's that. Like it's reasoning is a nuanced thing, really, frankly, and I don't think definitionally it's something that you can say, oh, this is a reasoning AI and this is a non-reasoning AI. It's a line, it's a scale. And what it means is that it's getting smarter and smarter about the micro decisions, and it's able to actually make micro decisions. And I'll give you some examples in a minute. If you go back uh, to Ashok Ghoswami, VP of AI at Tesla, he gave a talk in October of 25, and and it was the first time that he that Tesla talked sort of in depth about the stack. And he left us with some really good nuggets. And one of the things that he talked about, other than explaining what, and I mean, he said, we are building an end-to-end AI, and that is a very specific thing he's talking about there, which we won't, I don't want to depend on that, but he talked about that several times. And he talked about that without revealing the box. And what I mean by the box is he didn't say, here's the architecture, but he did say, we are training it end to end. So he didn't discuss the modularity within the architecture. He didn't describe any of the nuance, the blocks. He didn't do he didn't give a recipe for his competitors to come after and follow. But he did say that we train it end to end, and that creates this consistency to the perception and planning side. We'll leave that over here. We'll put a pin in that. But he did talk a lot about reasoning. And the first step in a reasoning system is that the system itself needs to explain externally why it's making the decisions it's making. Okay. And so Tesla, Ashok spoke about their architecture, saying that somewhere in the mid stack, meaning in the neural network, it outputs, you think about, we know about the inputs and the outputs of this system. We've talked about it probably 100 times here, but we talk about photons in, controls out. Okay. And when we talk about controls out, we usually talk about, in vehicle autonomy, three things: accelerator, braking, and steering angle. Right. You can add to that horn and a few other things, but really those are the controls. And they're like 2 or 3 degrees of freedom if you want to equate it to like humanoid robotics. So very small kind of output controls. But what Ashok said that is, no, we're doing more than that. We're outputting these reasoning tokens. So in the case of this, is like input tokens, output tokens, but also reasoning tokens, and sort of in mid stack, somewhere in that opaque box to us of their architectural neural net. They are outputting various little reasoning tokens that are, some people might use the word reflective. In other words, the system is able to describe itself. And those reasoning tokens then contextually can be pushed back in to the system as inputs, so that the system can know effectively, it can maintain state. It knows where it is. It knows what it's doing. It knows why it did the last thing it did, and it can approach the next thing it did with the knowledge of the last thing it did.
And whether that was successful or not.
What's that?
And whether that was successful or not.
Yes. And part of the reasoning is sort of like the success factor of the micro move, the control actuation that got the thing another 5 feet through the intersection, right? Or something like that. So when you decouple that and you start to think about what can you do with reasoning, well, what it allows the stack to do, and now we're talking about still this big, I'll call it monolithic, or at least opaque to us, neural network that's been trained on data. It's both been trained on imitation, which is in-field data or possibly simulator related data, and it's been trained through reinforcement learning, which is a different thing. We've talked about that in the past. And so now you're smartening the system. The more nuanced cases you put, it's almost like that is its reasoning to a certain extent, like because it's encoding. I mean, let's back up a step. Somebody made some comment the other day I thought was interesting. He said, it's kind of this like what I call a deconstructive comment about the technology of FSD, and he said, yeah, but a 17-year-old can get in a car like that and drive it. And then, of course, a bunch of us, I guess myself included, shit all over that because that's crap. I mean, what's happened is that 17-year-old has sat in his parents' car and he has watched thousands and thousands of drive scenarios without necessarily training for it, as his mission in life. And so he understands, we as humans, we gather that experience kind of in the background.
Mm-hmm.
And so if you deconstruct it back to like a first principles physics approach, that's not how people drive. They don't drive by knowing that. I mean, humans have a good way. Like if humans have a good way of knowing, like if some object was coming at you and you couldn't identify the object, right? It was some monolithic large block is coming at you at some rate of speed that you could. I mean, not like a bullet, but at some rate of speed that you could dodge. Your lowest level, neural network knows how to dodge that thing.
Right. Or make the best attempt. Yes.
Or make the best attempt. Right. And that's an important point we can bring up. But that's not how you go through an intersection. I mean, you're not just dodging cars as a general principle. You have a route. You have a desired path that you're going to. You have the way you've got a whole bunch of there's safety and social kind of courtesies involved in rules. There's all these things, and those are not first principle things in their general. They're a buildup of experience, and you could drive without ever reading a rule book, but then you're tested theoretically to at least know some basics of, this is what you do at a four-way stop. I mean, or without, whatever. So if we come out of that a bit and we try to think about reasoning as a general principle, what I would say is that version 14 of FSD essentially incorporated architecturally the model for reasoning.
Okay.
And it allowed Tesla to make, somewhere along the line, Tesla AI team recognized that they needed to chop the decisions down to smaller and smaller, more granular things that they could maintain state and no approach. So example would be, I need to navigate through a parking gate. Mm-hmm. Okay. This requires a lot of little things. Like it requires what people might say is effectively a state machine. However that's implemented, you have to know that I'm in the state approaching it, I'm in the waiting state, and I'm in the post-waiting state, right? You can think that without understanding what the word state machine or what that means. You can just think that through. It's like, wait a minute, the thing has to approach that gate. Now, it has to reason or know, what is this thing? Is it a gate that's permanent, in which case it's useless to do that? Is it a gate that will open? Yeah. Is it a gate that we can assume will open? That's a different thing. Like assume will open means the human must do something to interface to the system to cause that gate to open. In a parking garage, it may be the human needs to pay, or the human needs to wait and let the license plate be read, or the human needs to put in a code or flash a QR code or something, whatever, and then the system is sitting there and saying, I need to wait until, and then if the wait fails, at some point the wait might fail, right? Without any other input from the human, The thing may be sitting at a gate that, I mean, what if it's a gate that 99.9% of the time works just fine, but now the power's out,
Right. Or it's broken for whatever reason.
broken for whatever reason. So the system has to have another pathway. And so all that stuff that gets encoded largely through data now is available for Tesla to be able to see through the stack, the little reasoning components, and be able to make these. So now, if you take my parking gate example and you shrink it to smaller problems, about how you might navigate an intersection with pedestrians and stuff, you may, instead of just sort of a longer trajectory decision, you can chop that down into smaller micro decisions. And none of that necessarily tells us that it's thinking the way the human does. So I think we should dispose of the idea that we're trying to compare it to a human's idea of how a human so-called reasons, because I certainly don't understand how a human reasons. I just know how the AI reasons.
So let's, speaking of analogies and speaking of how things reason, I saw a post the other day that says, do not confuse this. It doesn't reason the same way that an LLM does. Now, the closest thing that I think that I see on a day in and day out basis to an AI reasoning is watching what Grok does
Yeah.
on a difficult problem,
Yeah.
where it says, okay, I'm going to go look this up on the web. Oh, that didn't work. I didn't find it. Maybe I could find it over here. Oh, that was interesting, but there's something wrong with that data.
Yeah, and right, that's that chain of thought, chain of reasoning type of thing is it. So I don't agree with that statement that it's not like an LM. It is like an LM, and it is trying to. I mean, think about what that going on there. That in fact is a state machine too, because it's waiting. It says, okay, I have this thing. I'm going to go research over here and here, maybe in parallel. I wait for those things to return. I collate the answers, between like different things, and then I may feed it back into the general LM to have it, sort of like, think about it this way, without being very, necessarily correct. It is sort of like you start with a prompt in that system, and the system says, okay, here's the question. I can put it straight through the LM like I did in the old days,
Yeah.
and just spew the answer out.
Right.
Or I can have a preprocessor, if you will, kind of break it up into parts and then send those parts off in parallel to different brains, different subcomponents of the LM. Sometimes that invokes a web search. And then if there were data come back from the web search, it goes to the LM again, right? That's what's happening. It goes to so now what's happening is that user prompt, with respect, it's a bit of a technical way of saying it, but with respect to the user, it's a bunch of asynchronous processes that have been invoked, and there is a collector, and the collector is sitting there, or there's something that's organizing the result stream. I would think that's a reasonable analogy to think about how a reasoning architecture works in vehicle as well, because you could do things. You could ask questions of the system in parallel. You could, you could do those types of things. What I do think, however, is it's a bit more potentially monolithic and cycle driven, meaning that you get these reasoning tokens and they ultimately become inputs to the system that drive the system to a different outcomes that then actuate the controls. So I think that
it seems like on the vehicle, it only has its data and its training. It can't go to the web.
And certainly what's true about a vehicle is it's a real-time system.
Right.
And that's an extremely important consideration. Right. I mean, you make that's why I said use the word asynchronous, in the sense that you send something off to an LM and it doesn't really matter if it's 30 seconds or 2 minutes. You may want time over accuracy or accuracy over time, but really it's not extremely important that now with FSD, you've got to get that cycle about 36 times a second through the system. So it's a real-time system, and it needs to operate as a real-time system so that you can make safe driving decisions. You can't ask an external source. You can't run FSD in the cloud. There's too much latency. You can't do any of those things. You have to run it on vehicle, on the inference computer at extreme frequency, 36 cycles a second. And so all of that stuff is really hard to do because you've got to get those output tokens. You got to shove them back in to get the system to effectively create those micro decisions to do its thing. And I think what we saw at NVIDIA's presentation for Jensen was a bit of a hand wave where he's like, well, the last mile is really hard, and Tesla clearly has the edge here because they have a fleet of 8 million vehicles, every one of them running in shadow mode, or every one on probably AI4 running in shadow mode. They can collect as much data or as little data as they want. And how would we ever catch that? Oh, we'll do it by reasoning. Right. See, we do reasoning and they do this. And that's not correct, because the word reasoning in terms of stack level approach first came up by 𝐒𝐚𝐽𝐿 𝐒𝐚𝐲's presentation in October, and that wasn't the first time that they used the word reasoning in-house. So Tesla, this is how Tesla is doing what it's doing. And what I tried to explain in a post about this is I said, it is the data that builds up this reasoning system to be able to allow it to make these good quality micro decisions as it runs through an intersection or takes an exit or avoids a pedestrian or anything else. And I guess maybe the inference by that presentation, sorry to double use that word, is that somehow reasoning is pure thinking without, it's almost like first principles thinking, and it doesn't rely on a trained set of data. I mean, that's hot garbage, because a neural network itself is a set of encodings of numbers that have been encoded by data. That there is nothing else there. I mean, inside it, it can be modularized. It can have these, kind of reasoning cycles or reasoning components or reasoning tokens that output and all this other stuff. But all the parameters of that thing are set through data.
Right.
So it can't, today in today's world is not, look, again, I want to say this out loud. I don't want to sit here and compare it to how does a human reason through an, I mean, we know what we know about FSD is it is a drop anywhere driving system. But it clearly knows about roads, highway, city streets, intersections. It knows about the principal components of what driving is, right? That's all about the data. The data has encoded that in the system. We as humans, some level of that is true. That's what we went back to, that the 17-year-old doesn't just approach an intersection. He was blind all his life. He couldn't hear. The very first day he turned 17, all of that's open to him, and he goes through that intersection perfectly, knows the rules intrinsically, knows how to manage it, and knows how not to piss anybody off or to, that's utter garbage, right? That's not what's going on. So, but instead of trying to use, it's like what I see a lot of arguments is like, oh, the 17-year-old or the human can do it this way, NVIDIA is doing it this way, and then Tesla's training on data, therefore they're not doing it this way. Those things are not these are not mutually exclusive things. It is the data that tells that 17-year-old how to do this situation this time, right? I mean, he may get through it. He may get through it even safely because, he has good reaction times as a 17-year-old versus, somebody like my age who reaction times have But what I get over that person is I get a wealth of experience to
Right.
draw upon, which allows me to say, I've seen this chicken before.
Mhm.
This is how you get through this circumstance in this type of intersection. Oh, I've driven on the wrong side of the road before in New Zealand. I can do it in the UK.
Yeah.
Um, um, and that amounts to saying, however my brain works, I've encoded data to do that.
Yeah.
I've encoded data. I've used data to encode my neural network to do
Mhm.
that.
Mhm.
Therefore, Tesla's doing that as well.
Mhm. Yeah. So the two thoughts that come to mind are one is that humans have intuition and they have emotion, at least those two things, and they also, in the case of a car, commonly have a backseat driver who can help them make these reasoned decisions.
Help?
So, so that would be a big difference between humans and any neural network or any
Well,
computerized neural network.
what's interesting is, I mean, we can hardly define some of these terms. I mean, I'm
Right.
not
Yes.
going to get into the neurology of it. I don't even know it.
Yeah, right.
But I'm not even sure that's the right word for it. Someone would correct me and say, no, that's not. You're not supposed to say neurology. In that case, you're supposed to say this or
Right.
that, or. Um, but I think is like when you step back and think about it, um, humans do have this box, this ability, uh, uh, a fight or flight mechanism that allows humans to avoid catastrophes and non-experienced some circumstance. Like if you see a dog and you say, "Oh, this German Shepherd is mean," and it gets out of the gate, then you think, "Oh, I have to. I'm not going to fight it. I'll flight."
Right.
But you know that German Shepherd. You knew it was mean. You knew these things about it.
Right.
Uh, if you saw some creature coming after you that you've never seen before, obviously you don't know if it's friend or foe, but if it's rushing at you in some particular way and you've never seen it, you're probably going to apply some base level
Mhm.
flight or fight mechanism that's just intrinsic, that's encoded, I don't know, DNA, whatever. Kind of let's say it's like the base level set down of your neural net.
Mhm.
But then now your neural net is gathering up all these experience bits over the years that move it to a higher order level navigation. So before we just talked about the raw fight or flight mechanism, but going through an intersection isn't really about that. I mean, it is, but it's not. And so now we have to manage we're not extreme for our life. We're just trying to get through the intersection to move on our route. We have a route in mind and we have these things. Um, and I think that if you think about it, the one thing that's true about humans is that they can get by in driving because roads were built for humans. I mean, we also have to see that part of this problem. We have to understand that roads were built for humans, for human, like we only can go at certain speeds because humans can only process at certain speeds.
Right.
Our visual cortex has a good latency of I don't know, like an eighth of a second from what we see to what we mentally see of the exact same thing. So we don't process light at the speed of light.
Mhm.
We have to go through a processor. We have to go through an inference cycle to get to the processing component of that. We may see the light at the edge of our eyes at the inbound speed of light, but our processing is still another eighth of a second delayed. So roads are built with this in mind. We may not think about that, but they are. That's the car speeds are governed by what we can do as humans. But at the very end of the day, humans are absolutely awful drivers. This is not, what's interesting about the entire conversation here is that FSD will, if it hasn't already, passed and will then lap significantly by an order of magnitude the safety of KPIs of the human driver. So there's no contest there at all.
Right.
So I think the takeaway points are that reasoning is intrinsically it's a difficult word to say. This is what a reasoning system is. It shouldn't be you shouldn't draw a straight line to a human and pretend that that's what it
Yeah.
is. You
Yeah.
have to think about what an AI is doing,
Right.
whether it's an FSD AI or an Nvidia grown AI or a Waymo AI. If it's doing the AI portion of it, these are all neural networks. They're mostly trained end to end. Blah blah blah. So we have to recognize that we are now talking about the machine level version of reasoning, um, and that Tesla, you know, put this in the stack early on. This is what
Yeah.
14 was about to a certain extent. They knew the reason it's taken a long time to get where we've gotten is that this is what's happened to them as they progress. They've had to deal with uh, I said in another podcast we were talking about, and this is a really interesting point, I think, is that uh, it's nothing like the real world or experience, real world experience data to harden the product to the point where it could succeed in the marketplace and in a way that meets all the criteria, checks all the boxes, safety, performance. What I mean by performance is I don't mean speed, but I mean like
Mhm.
what we assume the right behaviors of the system is, whether it's robotaxi and correct drop off, or it's the parking behavior of your FSD system, whatever. So Tesla's been at this with road miles for a very long time. And I think if we looked at the architecture, the reason we make these version numbers from 12 to 13 to 14 is there's some big architectural changes that occur. It's not just, oh, we've upped the number of parameters in this version. That's not what's going on here. Each iteration, Tesla is uh, changing a bit of the internal architecture to because because frankly they are they are seeing the world as it is. They're encountering the world as it is, and no engineer, no matter how good that engineer is, can be predictive of a problem that is inherently defined by its edge cases.
Yeah.
This is why I often say that the other catch up to Tesla is not simulation. It is not as if simulation
Yeah. Yeah. Yeah.
isn't
Yeah.
isn't awesome, materially important to Tesla and others, but it is not the magic elixir. It is not the thing that, and I'll tell you why. Because at one level, you could say, well, with infinite compute, I could have every piece of training data. That is a bit like the monkeys, infinite monkeys writing a
Right. Right. Right.
writing
Right.
a
Right. Yes.
Shakespeare play. So far, it hasn't happened,
Right.
and it probably won't. But you could get really close with a lot of compute. Um, but you couldn't reproduce that thing. That's the whole point of that. Uh, if you think about simulation, one of the ways Tesla uses a lot of simulation. In fact, the reason that architecture both validates,
Mhm.
but
Yeah.
it also is intrinsic to reinforcement learning, which is now a
Sure.
huge part of what they're doing.
Right.
Okay. But most simulation, I would argue, uh, I don't know, maybe over 90% of it starts with real world data that then gets augmented. So you start with either situational or backdrop template of this is an intersection. Let's pull it into the simulator. Let's rearrange some things.
Mhm.
Let's change the dynamics of things. Now, at the far extent of that, you could say, well, I built a simulator that um, that would allow. I made up an intersection. I made up a bunch of objects that are vehicles, pedestrians, dogs, cats, skateboards, and rats or something. And I then threw them at the intersection randomly and asked my vehicle system to navigate that properly. And that's horse dung, because you don't do that in simulation. You're not asking the system to just create random scenarios, because that's a huge waste of compute and is really not effective to try to train a system to navigate the, what we see now. So what you need to do in a simulator is you need to figure out, these are the edge cases. Well, how do you tell an AI these are the edge cases? You could suggest, well, I'm going to take this intersection and I have data that shows that I see two pedestrians walk. And by the way, the pedestrians left before they got the cross arrow. Common thing, it's like a jaywalking thing, but or a pedestrian changed his mind halfway out, turned, or the pedestrian was drunk and just started kind of wandering. But unless you're talking about, the Walking Dead, you're not going to have like a set of zombies just walking through an intersection. And so if you let a simulator just kind of pretend that it's going to be able to build edge cases effectively, it will build edge cases effectively, but they'll be so insanely not real that you can't bring it back to something that really would happen. So Tesla's extreme advantage here is that it's collecting these edge cases in field, and has built a very effective system for, if you think about, if you're running, let's say you buy a brand new Model Y, you take it on a 50-mile trip to get dinner, whatever. That system is run, and you don't know anything about FSD. You've never heard of FSD. That system's running FSD the entire time, and it comes across something in an intersection, and they've got code. By the way, part of their reasoning system, and part of the reason they built the reasoning system, is that they need to be able to cherry pick data. Right. So the system has to be able to flag by its reasoning tokens things that wouldn't have gone well had the FSD been in charge, or things that would have gone differently than the human driving decision had FSD been in charge, and snapshot that data set to be able to bring that back to Tesla. If there's not a reason, excuse the word, overuse of the word, if that's not a reason to build a reasoning system, what is? So you can see early on that the somewhat semantic output of the system can describe itself, and has for a very long time, because they've been wanting it. If you said, hey Tesla, or let's run this in shadow mode and collect all the data, that's a non-starter. Can't do that. Okay. If we could do that, we'd incur great transmission cost, regardless of, just a lot of, at some point it would overrun the memory on the local device. And so you'd be throwing some of it out anyway. You may be throwing out good data. So, just to put a bunch of data. So instead, what you're doing is you're saying, I want the system to cherry pick good data sets. I call them data sets, like data segments. Like here's where the event occurred. Here's 20 seconds before, 20 seconds after. So we have the full spectrum of what's going on. And then they can use that for training, validation, simulation, templating. With the templating, what I mean by that is they can say, oh, this is an interesting situation, intersection. Yes, we will add more pedestrians, or we'll add some random behavior of the pedestrians, but we're not going to just throw zombies in the middle of the intersection, right?
Unless it's San Francisco.
Yeah, there are a bunch of zombies. Unfortunately, they're not been infected by some. Well, maybe they have been infected by a virus. Let's just leave this one out. Let's leave this one. Let's let that dog lie. Yeah. So I think in summary, the point of this whole discussion is that on cue, Nvidia showed up to do what we expected, or at least I expected, or many of us expected them to do.
Mm-hmm.
Talk about more pickaxe, shovels, genes for gold miners. Those gold miners being the OEMs, and try to hand them a toolkit. And it's really like copy and paste a bit of what Tesla's doing. It's a great strategy, by the way.
Yes.
Like if you're Elon, and I don't mean this I'm sorry, if you're Jensen, and I don't mean this really cynically, I just mean just kind of like you sell a whole bunch of GPUs to Elon, you let him cook, you find out what kind of stuff he cooked with, then you do a light version of that dish, and you start to say, well, you can go and use this recipe for free.
Yeah, and in fact, the interesting part is that Elon would be fine with that.
I think he said he's fine with it.
He said he's fine with it.
Yeah.
And he's fine because he wants the success of the entire system, and he knows he can't do it all by himself.
Yeah, I mean, in a future world for Tesla, right? Let's say that Mercedes or Ford or somebody has, level 5, hands off, drive anywhere, unsupervised vehicle autonomy. We shouldn't call it FSD. It's not FSD, but vehicle autonomy in 2 years. Okay.
Yeah.
So that's something that's going to happen at some point. There's always going to be, maybe people think it's like Android to iPhone.
Yeah.
And that somehow that, happens right away. I mean, iPhone's iPhone's a little bit easier to copy than FSD, to be frank, because of all these things we're talking about. But at this point, in 2 years, where is Tesla? In 2 years from now, Tesla has a couple million rideshare units running planet Earth, and is popping those very units out of the factory every 10 seconds.
Yeah.
And not only dominating rideshare, but holistically redefining transportation, and further has made 2 years progress from where it was.
Right. Exactly. Yes.
So this is going to be very, very difficult to catch a vertically integrated company that isn't sitting around on its laurels waiting for, I mean, I don't want to be, I'm just saying, there's engineers working at Tesla on Saturday nights. There were engineers in Austin running around on New Year's Day.
Yeah.
Okay. And New Year's Eve. There was a post late on New Year's Eve, no popping of the champagne. You're at the office working on. Yeah. So.
All right. Well, I think I get it better now. That doesn't mean that I'm ready to go to work as a AI engineer at even the lowest level engineering place, but I think I understand reasoning a little better.
Can I make a suggestion to people who are watching this? Because sometimes I'll mumble stuff around and I won't, and I'll make mistakes in what I'm saying. Go read my article on reasoning. Yeah. I dropped that article, I think, in October of this year, last year. Go read that article. It give you at least some sense of what, it'll tell you that Tesla's been on this game publicly since October, but before, and it should define this a little bit better. Read some of my posts that are recent about the subject matter. And it should give you a lot of, look, I literally just woke up thinking to myself early in the week of CES that this is another buying opportunity for Tesla stock.
Right.
Yeah.
100%. And it looks like it was going to be, as the stock is up nicely today. All right. And Phil, again, like it, love it. Always learn something, and we'll look forward to the next one.
Yeah. Sorry. You were going to finish. I was going to finish. Go ahead.
Were you going to finish? I'm going to finish.
I was just going to say Happy New Year to everyone.
Yeah. I've already said that a few times. Yeah.
I'm sorry. Did we say that?
It's your turn. Yeah.
Oh, well, Happy New Year to everyone in a sincere way. And, I think 26 will be epic.
Bonkers.
It's
Absolutely nuts.
yeah. I mean, yeah.
Yeah. All right. Thanks, Phil. And to all of you out there, it's been great talking to you.